Morning. So, when sir the last class? Hello. Morning. Good. Okay. Okay. So in the mid, no class was there. Study. Okay. Which track? Okay. So that is I will take the track 2. Physics track 2. Subject is also required, na? Okay. So up to what topic sir has taught? Anybody will say, sir has completed up to what? Error completed. Okay, resistance in parallel completed, error completed. Time period problem of the error, it is completed. Okay. So first I will start with a significant figure, then I will come to the instruments. Okay. So significant figure is what? Like this year also they asked one question from the significant figure. In the NEET also they asked the question on significant figure, but they ask in chemistry. So we have to learn the significant figure for the physics as well as for the chemistry also. Okay. So first thing, what is a significant figure? So definition they are not going to ask, but actually the significant figure is what? Like in any data, suppose I am writing any length I measure 1.23 centimeter. Okay. So I measure up to the decimal 2 place of the centimeter. So everybody can say this one is certain in this, if we are observing the reading properly. So this one we can say one big division has crossed. Okay. Then two small division has crossed. So 1 and 2, these here in this data 1 and 2 are certain, means everybody can say this 1 and 2 has crossed. Maybe the third data, that is 3, in the 3 what may happen, maybe it is a close to the 4, but you are saying it is a 3. Maybe it is just crossing the 2, you are saying it is a 3. So the problem is only with the third one. Okay, so here 1 and 2 are the certain digit and 3 is the uncertain. Then uncertainty will be in the third digit. Okay, so what is a significant figure? Basically it is the sum of the certain digit plus one uncertain digit, summation of the certain digit and one uncertain digit. So like that, here we can say these two digits are certain and third one is uncertain. So certain digit 2 and one uncertain digit 1. So how many significant figure it has? 3. So the data 1.23 centimeter has 3 significant figure. That is the just definition of the significant figure. Okay. Yes or no? Okay. So significant figure mainly we deal in a physics or chemistry. So when the data came from any experiment, when the data come, I will say all the rules, just wait. So when the data come from any experiment like this data, so it means I measure this length by using any device, and by that device I am saying the length is 1.23 centimeter. Like I am measuring the mass, I am using any device, from that I will say the mass. Okay, some gram or some kg. So significant figure mainly we deal with the data that is coming from any observation or experiment or any device. Okay, understood? So first we have to learn how to decide the number of significant figure in any data. What are the number of the significant figure? How we will decide? So there are some certain rule what we have to follow to find the number of significant figures. Okay. So the first rule is what? All non-zero digits are significant. Okay. So if any data contain non-zero digits, so all non-zero digits we will take as a significant. All non-zero digit we will take significant. Like or decimal also you can put. So 1, 2 dot 12.35. How many significant figure it has? So all are non-zero digits. So directly we can say it has the 4 significant figure. Okay. I think no confusion in this. So all non-zero digit we will take as a significant. Okay. We will not find what is the number of certain digit, what is the uncertain digit. That was a definition only. There we have to follow the rule to get the number of significant figures. Okay. Number 2, all zeros between non-zero digits are significant. Okay. So all zeros between non-zero digits that we are taking significant. Like how many significant figure? 5, because this 0 is coming between the 2 non-zero digits, that is one is the 2, one is the 3. So it has, we can put the decimal also. If it is a decimal, then like suppose I am saying this. So how many significant figures? Same rule we can apply. So it has significant figure is equal to 5. Number 3, if data is less than 0, then all zeros just right of decimal are insignificant. So if the data is less than 0, then all the zeros just right, not all of the right, just right of the decimal, all the zeros we will take as insignificant. So they will not contribute in the significant figure. Okay. Like suppose I am saying 0.0023. So this number is less than 1. Why? Because 0 point something is there. So this number is less than 1. So all the zeros just right of the decimal. Just right of the decimal. How many zeros we have? These 2 zeros. These 2 zeros are insignificant. So how many significant figure it has? So these 2 zeros are insignificant. So only 2 non-zero digit remaining. So significant figure, what we can say? 2 significant figure. Okay. Number 4. If number or data does not contain decimal, then all trailing zeros are insignificant. If data does not contain decimal, then all trailing zeros are insignificant. What is the meaning of the trailing zeros? That is the rightmost zero. After that, no any non-zero digits are there. All rightmost zeros. After that, no non-zero digits are there. So those zeros are called trailing zeros. All rightmost zeros. After that, no any non-zero digits are there. So they are trailing zero. Like, but the condition that data does not contain decimal. Like suppose I am saying 12500. Okay. So in this last two zero, after that no any non-zero digit is there, and this data does not contain decimal. So these 20, what you will take in significant. Okay, so how many significant figure it has? 3 significant figures. So it will have the 3 significant figure. Any problem in this? Okay. Number 5. Now suppose the number contain decimal. Then trailing zeros will be significant. Then trailing zeros are significant. When number now, it is not actually number, it is a what? Any experimental data or any measured data. So if the data contain the decimal, then trailing zeros you will take significant. So like suppose I am saying 1.2500, the same number, but I put the decimal here. So if it contains decimal, so trailing zeros will be significant. So how many significant figure it has? 5. So maybe you are thinking in the class 3rd or 4th when we were learning addition of the decimal quantities. Okay, so what we were doing there, we were doing any zeros we were adding. Like suppose you have to add suppose, okay, you have to add these 2 quantities. So what we were doing there, we were putting any number of zeros right of that, and easily we were adding 7, 8, 4, this, okay. But here, this zero, what the zero we are taking after the decimal, all these zeros are significant. Why? Because any number of zero we can put after the decimal. So why these zeros we are taking as significant? Everybody is getting my point or not? Okay, so according to the rule, these zeros has to be significant. Now, why what I said, significant figure, we deal not with the number, any number. Significant is mainly deal when the data came from any experiment or the observation or from any instrument. Like suppose I am saying any length I measured in a normal centimeter scale, what we are using normal centimeter scale. Any data is coming from the normal centimeter scale. So you will say the suppose length, you will say the length is like 2.1 centimeter, you can say 2.5 centimeter like that. Will you say 2.20 centimeter like this? Suppose you are using the normal centimeter scale and you are sending the data to someone, and that data you will write as, suppose you are getting the 2, so you will write as 2.20. That 0 is a meaningless here. Why? Because when I'm sending the data from the measuring the length by using the centimeter scale, so I know that centimeter scale can measure only up to decimal 1 place, because least count of the normal centimeter scale is what? 0.1 centimeter. Less than that it cannot measure. So when I'm sending the data, that data or that length I measure by using the centimeter scale. So I will not write 2.20. I will write up to the decimal 1 place only. Then the other person will get to know, okay, this length has measured by using the centimeter scale. Understood or not? So that's why this 0 unnecessary in the experimental data, we will not put the 0 unnecessarily. Like any number of 0 I will put and I will send the data. I will send the 0 if I am putting the 0, so this 0 has some meaning. Here, this data if I am putting, so that the other person will get to know this data came from the vernier calipers, because it is measuring from up to the decimal 2 places. Like suppose I put the decimal 3 place, so that person will get to know that this data came from the screw gauge. Understood or not? Okay, so that's why here this 0 has the meaning. So that's why here it is saying if the data contain the decimal, then trailing zeros we have to take significant. Okay. So means like this data I'm saying, so this data I'm saying, it means this data that it came from any instrument. So that instrument can measure up to the decimal 4 places. That's why these all 0 we will take as a significant. So total number of significant figure we will have 5. Okay. Got it? Scientific notation like a into 10 to the power b and rounding off, that is completed or not? Scientific notation also not completed, rounding off. Okay, no problem. 5 to 10 minutes first I will discuss that also after this points. So some basic idea maybe about the scientific notation, like some when we write the number a into 10 to the power b, I will say, but in this rule we required that scientific notation. Okay, so like suppose we are converting the any unit like kilometer to the meter, kilogram to the gram. So in the conversion of unit, we don't change the number of significant figure. We cannot change the number of significant figure when we are changing the unit from one system to the other system. Okay, so in changing significant figure does not change. Okay, in changing system of unit, like suppose I am changing from the kilometer to the meter, so in that I cannot change the significant figure. Okay, so one example I will give for this. Suppose 1.20 kilometer you have to convert into the meter. Okay, so I think everybody know the conversion factor. 1.20 kilometer we have to convert into the meter. Who will say what is the answer? 1 kilometer is equal to how much meter? So that is 1,000. So we will say what? That is a one option what we have. I can write like this. Because 1 kilometer is equal to 1,000 meters. So when you will multiply this by 1,000, you will get this. Okay. But the problem is what? 1.20 kilometer. How many significant figure it has? How many significant figure? 3 significant figure. 1200 meter. How many significant figure it has? 1200 meter. How many significant figure? Somebody is saying 3, 2, 4. Why these options are coming? Why 4? Why 4? So these zeros, last 2 0 are the trailing zero. Last 2 0 are the trailing zero, and trailing zero are insignificant when the number does not contain decimal. So this number does not contain decimal. So this 0 will be insignificant. According to that, how many significant figure it has? 2 only. In module, in some books they have given, like when the unit is there, we will take significant, but we have to follow the NCERT. NCERT, trailing zeros, whether the unit is there or not. Trailing zero, you will take insignificant if it does not contain decimal. Okay, so that's why here these 2 0 are insignificant. So how many significant figure it has? 2 significant figure. But in the conversion of unit, I cannot change the significant figure. So only one option, and that relation also I cannot change. 1 kilometer is equal to how much meter? So what is the way to write this? We can write like this. Okay. Now, what is the significant figure in this? 1.20. How many significant figure? 3 significant figure. And the 10 to the power something, it does not contribute in the significant figure. Now, left hand side, how many significant figure? 3 significant figure. Right hand side, how many significant figure? 3 significant. So that does not change the significant. So we cannot change the significant figure in the conversion of one system to the other system. Understood? So for some cases we have to use this notation. So that notation is called the scientific notation. Wait. Now audible? That was a battery problem. Okay. Now everybody understand this? Okay. Okay, so these are the rules to determine the significant figure. We will do the addition and subtraction and all the rules after the rounding off. Okay. So rounding off already we use it earlier also. So suppose any data rule, no need to write, just listen the examples only. So suppose I am asking 1.37. Okay. This I want to write up to the decimal one place only. Decimal one place only. So it has the decimal two places. I want to write this up to the decimal one place. So the rule we have learned, when the digit that you want to replace, okay, remove, if it is a greater than 5, then preceding digit increased by 1. Okay. So here I have to remove the 7 and 7 is greater than 5. So when the digit that has to remove greater than 5, then preceding will increase by 1. So you will get what? 1.4. Okay. Second example, 1.34. Suppose 1.34 I am giving, and I want to round off up to the decimal one place. Okay. Now here I have to remove the 4. Okay. So 4 is less than 5. So 4 is less than 5. So preceding digit will remain unchanged. If the digit that you have to remove, it is a less than 5. So preceding will be unchanged. So what you will write then? 1.3. Okay. Next, 1.35. So the digit that has to remove, if it is a 5, greater than 5, increase by 1, less than 5, remain same. The digit that has to remove, if it is equal to 5, then there is a 2 rule. If preceding digit is even, then it remain unchanged. But if preceding digit is odd, then it will increase by 1. So here I have to remove the 5. So when I have to remove the 5, I will check the previous digit. Now preceding digit is what? 3. 3 is the odd. So when it is the odd, then preceding digit will increase by 1. So then you will get what? 1.4. Okay. If this you have to round off. Now again you have to remove 5. So 5, so you will check for the preceding. Preceding is a 4. 4 is a even. So when it is a even, then it will remain unchanged. Then what you will get? 1.4. Okay. So these 3 rules has given in NCERT. Greater than 5, less than 5. Okay. And that type of example is there. But sometimes it is that is more chance is there. Like suppose I am saying, I just put another 0. After the 5, I put the 0, but I have to round off up to the decimal 1 place. Okay. So basically, I have to remove this. I'm asking decimal 1 place, 1.250 I gave, and I want to write up to the decimal 1 place. So I am not removing 50. I am not removing 50. So place value is what? 5. Exactly it is a 5 because after the 5 it is a 0. So then in that case, I am removing the 5. So I will check for the preceding one. Preceding one is what? Even. Then what you will write? 1.2. Yes or no? So ultimately we are what? I am removing the 5 because after that non-zero is there. So any 0 I can put. So I am removing the 5. Okay. So 5, that is a greater than what? Equal to 5. So we will check for the preceding. Preceding is even. So that's why it is a 1.2. Now suppose again you have to write to the decimal 1 place. What you will write? 1.3, 1.4, 1.4, 1.3. Okay, now again what I said, we will not see I am not removing 32. I am not removing 32. Like what you will get? Here is a 3, 2. So maybe it is a chance like 3, 3, 3, 4, 3, 5, 3, 6, 3, 7, 3, 8, 3, 9. Then it will become 4. Then it will become 4. So ultimately like 1.34. In a 1.34, what you will write? It is a 3, 2 means what? Like it is the less than 4, more than 3. We will see like that. After the 3, non-zero digit is there. Okay. Like up to the 3, 9, it is a 3. When it becomes more than that, so it will become 1.34. 1.34, so 4 is still less than 5. Yes or no? So less than 5, so preceding will remain unchanged. Okay. So I am not removing 32. So place value is the 3. So it is a more than 3, but less than 4. More than 3, but less than 4. So less than 4 means less than 5. Less than 5, so preceding will remain unchanged. So what is the answer you will get? 1.3. Yes or no? Everybody got or not? Okay. Now last example. What is the answer? Again you have to remove this. So I am removing not 5. I am not removing 5. I am removing more than 5 because after the 5 non-zero digit is there, 2. So it is not the 52. It is a more than 5. Okay. So then more than 5, only one rule is there. We don't check for the even. Otherwise, if you're like for the odd, you are thinking I'm making it even. Now what is the answer? What is the answer now? 1.4, 1 point. That's why now I changed because maybe the people were taking odd and then they were increasing. 1.4. Next answer. Answer is 1.5. Why 1.5? So you are checking that, you are saying that I have to remove the 5. So I am checking the preceding digit. Preceding is the what? Even. So it will remain unchanged. But you are not removing 5. You are removing more than 5. Why? After the 5, non-zero digit 2 is there. So its value is what? More than 5, less than 6. So place value we can say more than 5. Place value is more than 5, less than 6. Yes or no? Like here 50. 50. So here you are taking the place value is 5. Okay. Here you are taking this 3. This 3 place value is more than 3, less than 4. More than 3, less than 4. Here this 5. This 5 place value is what? Here more than 5, less than 6 we can say. Yes or no? Okay, so it is a more than 5. So place value, because here after the 5 non-zero digit is there. So its place value is the more than 5. More than 5, so no any two rules is not there. Only one rule is there. More than 5, preceding digit will increase by 1. No even not condition is there. So it is a more than 5, so preceding will increase by 1. So what you will get? 1.5. Now everybody got? Okay. So this is the rule of the round off. 1.352. 1.352 is equal to 1.4. Okay then. Now next is a scientific notation, that is what? A into 10 to the power B. So sometimes we have the very large number or very small number, like mass of the earth we write as a 10 to the power 24 order. So we cannot put the 24 zeros. So that's why we have used this notation, A something into 10 to the power B. Okay. Like electronic charge. Electronic charge is very small in a unit of coulomb. Now 10 to the power minus 19. So we cannot put dot decimal then 0, 0, 0, 0, and then we will write 1 and 6. So that's why for very large data, for a small data, we use this notation. Okay. But there is a condition with that when we have to write this. So here A, we have to write A must be between 1 to 10. Equality is there, we can take equality at 1, but it has to be less than 10. Any number that is between 1 to 10 we can take as A. Okay, getting or not? Because when it is at 10, when you will take the 10 here, so 10 like 10 into 10 to the power 5. 10 into 10 to the power 5 directly I can write as what? 1 into 10 to the power 6 or 10 to the power 6. So that's why we are not taking the equality at 10. It has to be less than 10. 9.9 is okay, but we cannot take as a 10. Okay. So the condition of the A is this, okay, and B may be positive or negative. Okay, so B may be positive or negative. Like maybe so many notation you have seen, like electronic charge. Electronic charge, if you remember that, you write as a 1.6 into 10 to the power minus 19 coulomb. So here A value is what? 1.6. That is a less than 10, more than 1. Mass of electron we write 9.1 into 10 to the power minus 31 kg. Now again you can see here A value is what? Less than 10, more than 1. So that's why this is a rule to write in this notation. Understood or not? So sometimes they ask, like, what is the order of the, like in the atomic structure maybe you have learned, what is the order of the radius of the atom? So order of the radius of atom means they are not asking the A value. They are asking what is the power you will say. What is the power you will say? So power is what? 10 to the power minus 10 meter or 1 angstrom. Order of the radius of the nucleus is the 10 to the power minus 15. Okay, so when they don't need exact value, they need only what is the 10 power you will put. So for that we required this notation. Understood? But that condition we have to follow. The A value we will take between 1 to 10. Everybody got or not? Okay. So in some cases, like they will ask the order of magnitude. So for the order of magnitude, we have to follow one rule in NCERT that they have given. When the A value, if A value is between 1 to 5, means A value the range of the value of A is what? 1 to 10. But they are dividing the A in a two part. One value is what? Between 1 to 5. One category they are taking 1 to 5. When the A value is between 1 to 5, I am using the notation is what? A into 10 to the power B. A into 10 to the power B. If A value is between 1 to 5, then order of magnitude is equal to B. So they ask what is the order of magnitude in this number? What is the order of magnitude? So order of magnitude, first we will write in this notation, scientific notation, A into 10 to the power B, and we will check the value of A. If the value of A is between 1 to 5, there is an equality at 5, okay? 1 to 5, then order of magnitude directly you will take as B, okay? But if A is between 5 to 10, means more than 5 and less than 10. No equality is here. More than 5, less than 10. Then order of magnitude, you will take B plus 1. I will say the example first. Okay. First write the rule. If A is between 1 to 5, then order of, first we will write in the notation A into 10 to the power B. Okay. Then we will check the value of A. A has a condition is what? It has to be between 1 to 10. Now we will check the value of A. If it is between 1 to 5, equality is there both cases. Then order of magnitude directly we will take as the power of 10. So this we will take as the order of magnitude. But if A value is greater than 5, less than 10, then order of magnitude we will write B plus 1. So it will increase by 1. This, everybody understood this rule or not? Okay. Like first example it is written here. Like electronic charge. Electronic charge I am saying that 1.6 into 10 to the power minus 19. So it is of the form A into 10 to the power B. Okay. If I am asking what is the order of magnitude in the electronic charge in the unit of coulomb, what is the order of magnitude? So we will say what? 1.6, that is a less than 5. Okay. Then we will see the power. What is the power here? Minus 19. So what is the order of magnitude? We can say minus 19. Yes or no? So then directly if the A value is less than 5, less than or equal to 5, then directly I can say order of magnitude is a B. So what is the order of magnitude? Minus 19. Now come to the electronic mass. Electronic mass is 9.1 into 10 to the power minus 31. You have to add 1, Priyanka. Then minus 31 is there, na? So A value is the 9.1. A value is more than 5. More than 5, then order of magnitude is the B plus 1. So B value is the minus 31. Minus 31 plus 1, what you will get? Minus 31 plus 1, what you will get? Minus 30. Minus 31 plus 1, you will get minus 30. Here B power is, B value is what? Minus 31. Then A value is more than 5, so it will increase by 1. So minus 31 plus 1, you will get minus 30. Got it? Okay. Like more example. Suppose I am saying 501. What is the order of magnitude? 501. What is the order of magnitude? Order of magnitude. What is the order of magnitude? First convert into that scientific notation. How you will convert? 5.01 into 10 to the power 2. This number has to be less than 10, more than 1. This everybody okay or not? I can write this or not? Say yes or no. Okay. So this is the right, na? Because according to the condition of A, that is the right. Now A value is what? 5 or less than 5 or more than 5? This value 5.01, it is a more than 5 or less than 5? More than 5. How you can say 5? It is a more than 5. Now, something is more, but it is a more. 0.01 is more, but it is a more than 5. Okay, so more has no limit. More means more only. So it is a more than 5. So when it is a more than 5, order of magnitude will increase by, like, it will be the b plus 1. Now b value is what here? 2. Then what the order of magnitude you will get? Order of magnitude is equal to 2 plus 1. That is equal to 3. Understood or not? Don't apply the round off there. Directly see the value of the A. A value is what here? 5.01. 5.01 means it is a greater than 5. Greater than 5, so order of magnitude, what you will write? B plus 1. So answer is the 3. Okay. Now, okay then. So round off is okay and order of magnitude is okay. Okay. We know, we have learned the rules of the significant figures. Okay. Now, significant figures in so mathematical operations means addition or subtraction, multiplication or division. So in what rule we have to follow in the case of the addition or subtraction? If they are asking, write the addition up to the correct significant figure. Okay, they will not ask that add these two quantity. They are asking, it means they are asking for up to the correct significant figure. So what is the rule for that? So first one is the for addition and subtraction. Okay. So in addition and subtraction, like the number does not contain decimal. Data does not contain decimal. So we will follow the normal addition rule what we are doing earlier. So number does not contain decimal, so we will add normally. Okay. And that what result we will get, we can say this is a result up to the correct significant figure. But the number is containing the decimal. If the number is containing the decimal, then resultant addition or subtraction will have decimal places that is equal to the minimum decimal places among all the number added or subtracted. So I am writing here, if in addition or subtraction, number of decimal places in resultant is equal to minimum number of decimal places among all the numbers. Okay, so suppose you are adding the 2-3 numbers. What I said, if the numbers does not contain decimal, no any rules are there. Okay, but if the number are containing the decimal, so in addition or subtraction, number of decimal places in the result, what we will take, it is the equal to the minimum number of decimal places among all the number added or subtracted. Okay, so for example, suppose these two number you have to add. Okay, that is a data that these two data you have to add. So first number contain, left of the decimal we will not see, integral part we will not see. Now the decimal place we will see. First number has how many decimal places? 3 decimal places. Second number has how many decimal places? 2 decimal places. Okay, So the result will have how many decimal place? Equal to the minimum decimal place. So among these two, how many minimum decimal place we have? 2 decimal place. So result will have only 2 decimal place. So if it is required, then we will use the concept of the round off. Okay. Then first we will do the normal addition. So it is what? 6, 7, 5, 5, 1. Okay. But I have to write up to the decimal 2 place only according to the rule. So it means I have to remove the 6. Now I have to remove the 6, then we will use the concept of the round off. The digit we have to remove is a 6. It is a more than 5. So preceding will increase by 1. Okay. Then what you will write? 1.5. 15.58. That is the answer up to the correct significant figure. Understood or not? Everybody got this rule, addition rule? It is okay? Okay. Otherwise, if the different units they have given, one quantity they have given in a kg, one quantity they have given in a gram. So first we have to convert the unit, same unit, then only we can add. Okay, and we will follow this rule for the addition. Okay. Like in the subtraction of the data, it is the same rule is applicable. Okay, we will not see the significant figure, we will see the decimal places, and there is a chance, probability is there, like you will get number of significant figure lesser, number of significant figure may decrease. Okay, but we have to follow the decimal place only. So in the subtraction of the data, it is possible that we can get the significant figure lesser than the given. Okay. So one example I will say, that example has given in NCERT also. Suppose I am saying subtract 0.307 and 0.304. We have to subtract. Okay. So how many decimal place the first number has? First number has 3 decimal place, second number has 3 decimal place. Yes or no? And how many significant figure it has? So 3 significant figure it has and 3 significant figure it has. Both number has 3 significant figure. Now when you will subtract, what you will get? 7 minus 4, 3, 0 minus 0, 0, 0. Now 0.003, how many significant figure? So this number is less than 1. Less than 1, so all the zeros just right of the decimal are insignificant. Rule number 3. So that's why these are insignificant. So how many significant figure you will get? 1 significant figure. Getting or not? So here, according to significant figure is decreasing. Okay, that is possible. Everybody got or not? Okay. Significant figure we cannot increase, because experimental data we cannot increase the resolution in the calculation. Or any data is coming from the centimeter scale, so I cannot get that data. Final addition is the decimal 2 places. When I'm adding the data, that is given only in the decimal 1 place. So that's why in the result addition or subtraction, decimal place will not increase. It is possible that significant figure may decrease, but it will not increase. Okay. So in the subtraction of data, it is possible that the number of significant figure may decrease. Okay. Completed? Okay. Next rule is for the multiplication and division. So first, in multiplication or division, number of significant figure in resultant, number of significant figure in resultant will be minimum number of significant figure among all numbers. Okay, so in division and multiplication, we will not see the decimal place. In the multiplication and division, we will see the overall significant figure. Okay, and in the resultant, like product or the division, number of significant figure in the resultant will be equal to the minimum number of significant figure among all the given numbers. We have to take the minimum number of significant figure. Like one number has given 4 significant figure, one number has the 3 significant figure. So when I am multiplying them, so number of significant figure what I will take? One has 4, one has 3. So which has the minimum, that we will take in a resultant. So resultant will have 3 significant figure. Understood? So in the multiplication or division, number of significant figure in resultant will be minimum number of significant figure among all the number. Okay? Understood? So like one example, suppose I am saying mass of the body is equal to 5.74 gram and the volume of the body is 1.2 centimeter cube. Okay? Then you have to write the density of the body up to correct significant figure. Density of the body up to correct significant figure. So density, first who will say what is the formula of the density? Mass upon volume. Density formula is what? Mass upon volume. It means I have to divide the two number, mass, that mass data they have given 5.74 and the volume they have given 1.2. Now mass has how many significant figure? This is the 3 significant figure. Okay. Volume has how many significant figure? 2 significant figure. Okay. Now in the density, how many significant figure you will have? 2. Minimum among the all. Okay. So you will divide it. So 5.74 upon 1.2. Okay. So after dividing, first you will get what exact you will get? 1, 4, 12, 4 za. And then around 7, 12, 8 za, 96. 1.78 around you will get. Okay. So 1.78. So it has one. If I'm writing 4.78. So 4.7 has how many significant figure? 3. But I need only 2 significant figures. So I will use the round off concept. So 8 I will remove. So 8 I have to remove. So preceding I have to increase by 1. So then answer what you will get? 4.8 gram per centimeter cube. Okay. Completed. Now next, that is also the example of NCERT. Length of the rectangle L is equal to 16.2 plus minus 0.1 centimeter and the breadth is equal to 10.1 plus minus 0.1 centimeter. So means in the measurement of length, error is the error may be the 0.1 and in the measurement of breadth, error may be the 0.1 and the true value they have given 16.2 for the length and 10.1 for the breadth. Now first problem is what? What is the percentage error in the area? First one is the percentage error in area and second one is the area with error. Okay. So percentage error, that everybody I think know the formula. So here area, we know that area of the rectangle is what? Length into breadth. Okay. So area I can write as A is equal to LB. So when there is a product is there or division is there, we first calculate the fractional error. So fractional error, how we can calculate? Delta A by A. That I can write as delta L by L plus delta B by B. This is the fractional error in the area. That formula we have. For the percentage error, what we do? We multiply 100 on both sides. Okay. Okay. That I think everybody now sir has said this formula for the area and any quantity that is in the product. We can find by this way fractional error. Okay. Now to calculate the percentage error, what is the delta L? Error in the length. Error in the length is what? 0.1. So I can write as what? 0.1 by 16.2. Okay. plus delta B is what? 0.1 upon 10.1 into 100. So when you multiply this by 100, so this will become what? 1 upon 162, 100 upon 162. So 100 upon 162 means 16, 6 are 96, around 0.6 you will get. And this you will get 1 upon 100 into 100, so that you will get 1. Multiplication you will do, okay? So then from this we can say it will come 1.6%. So percentage error we can get what? 1.6%. Yes or no? This type of problem we have already done. Are yes or no? Okay. Now second one is the what? Area with the error I have to calculate. So I am giving the 1 minute to everyone. You will say the area. Area means true value of the area. So true value of the area, how you will get? True value of the length into true value of the breadth. You will get the true value of the area. And then you have to calculate with error. Error means delta A. You have to calculate delta A. Okay. So up to the correct significant figure, you have to say the area A plus minus delta A. Okay. What you will write? 1 minute I am giving. Everybody will solve. Okay, one answer came 164. One 164. So maybe the product, when we are taking the product, so area, everybody is taking the LB. So when we are putting the value 16.2 into 10.1, so exact first we have to calculate up to the right. Then we can use the round off and then we can say up to the correct significant figure. So I think most of you are getting what? 163.8. 163.62. Okay. So they are getting the 163.62. You will do the calculation. So, but we have to write in a 116.2. In a length, how many significant figure you have? 3. 10.1, how many significant figure? 3. So this has 3 significant figure. This has 3 significant figure. So in the product, we'll also have the 3 significant figure. Okay. So I have to round off this up to the 3 significant figure. So this I have to remove, this I have to remove. So this basically I have to remove this. So this is the more than 5. Then I have to round off the preceding one. So preceding one after round off, what you will say? 164 centimeter square. So this is the area up to the 3 significant figure. Everybody understood or not? So area is not a problem now. Now area is completed. Now I have to calculate the delta A. For the delta A, directly now I already calculated the percentage error. So I can say what? Delta A is equal to delta A by A. Percentage error we calculated na. So delta A by A into 100. That is equal to 1.6. So what is the delta A you will get? 1.6 into area. So like this type of calculation, first we will put the true right value of the area. Then after that we will use the concept of round off. So 163.6 you can put. So 163.6 no more difference will come upon 100. So then approximately you will get the 2.6. Okay, 2.6 not percent. It is a centimeter square. Okay. 0.97, how? Here directly is 100, so here you will get 1.6 and you can divide, so 1.6 and 1.6, 1.6, 16 square is the 256, so it will be more than the 2.56, so around 2.6 you will get. A rough calculation you can do, na? 100 if you remove a 0, so here you will put the decimal, so it will be 1.636 into 1.6. So 16 is 256. So the answer will come more than 2.56. So that is the 2.6 I am writing. Okay. Okay. So what the area I can write? Area is equal to 164 plus minus. What I will write? 164 plus minus 2.6. 2.6. Now listen. Area I can determine in the integral part only, 164. Area I cannot determine up to in a decimal place. Area I cannot determine in a decimal place. So how I can determine the error in a decimal place? How I can write the error in a decimal place? Because it will violate the rule of the addition also. Okay, like suppose you are measuring any length by meter scale. Meter scale means each division of that scale is the 1 meter. No any other small division are there. Each division are 1 meter. Okay. So suppose from that scale you are measuring 164. From that scale you are measuring 164. Okay. So that 164, how much error you can do? Either 1 meter plus minus 1. Okay. So error you will write in a, no any error will not have any decimal place, because here you cannot, true value you cannot determine up to the decimal place. No any decimal place it has. Getting my point or not? So here 164 means I can say what? This 1, this 6 is maybe the certain, 4 may be uncertain. So the problem will be with the 4. It may be 4, maybe more than 4, maybe less than 4. Okay. So I will not write the decimal. Uncertainty is here. So there is no need of the decimal. Directly I will write the uncertainties at the 4. So I will write the error in the integer. I will write the error also in the integer. Another way we can think, area we will write as A plus delta A or A minus delta A. Area what I am writing? 164. If delta A I am writing 2.6. Okay. So area does not have decimal place. Delta A has decimal place. So after the rounding off, you will not take any decimal place, because this is the rule. Because in the addition, number of decimal place is the minimum among all the decimal places. Yes or no? Okay, so it means I have to write the error in now without decimal place. Okay, so that's why here what I will write, not the 2.6. What I will write out, I will round off it and I will say it is a 3. So 164 plus minus 3. That is the area with the error. Are say everybody got or not? Okay, so area we will not write the error as a 2.6, because area we are determining in the integer, so error also we will write in the integer. So here you will write, after rounding off this, you can say this is equal to 3 centimeter square, and this you will write plus minus 3. Okay. Completed? Now another type of problem. Suppose I am saying mass of one ball is, I have one ball, mass of that ball is 2.24 kg. Okay. Now I am asking total mass of 5 such ball. Total mass of up to correct significant figure. Total mass of 5 such ball up to correct significant figure. Okay. So what you will write? One ball mass is got 2.24 kg. I have to write the mass of the 5 such ball. So I will say what? 5 into 2.24. Okay. Yes or no? Okay. Now you will think that I am multiplying I am asking for the correct significant figure. So maybe you can think 5 has only one significant figure and 2.24 has 3 significant figure. So in the product, number of significant figure must be equal to the minimum number of significant figure. Okay. Getting my point or not? because I am asking the mass of 5 balls, so you are multiplying this by 5. But when any constant numeric multiplier is there, any numeric multiplier is there, like here 5, okay, this 5 is not the experimental data. This 5 is not came from any experiment. This 5 is only the multiplier. This 5 is only the multiplier. I'm asking the mass of the 5 ball. So this 5 is not coming from any experimental data. This everybody understanding or not? Okay. Okay, so means this 5 is not from any device I have measured. This is the numeric multiplier only. So this 5, if I am writing like 5.0, it is right. Because ultimately I will multiply with 5 only. Are say yes or no? If I'm writing this 5 as a 5.0, so their meaning is same, because ultimately I will multiply with 2.24. And I will not violating any condition of the instrument that this instrument can measure up to the decimal 1 place only or decimal 2 place only. So I can write this is a 5, or I can write as a 5.00. I can put any number of zeros after the 5, after putting the decimal. So in the 5, it is not the experimental data, it is the only numeric multiplier. So we can take like a infinite, it may have infinite significant figure. It may have infinite significant figure. So one has the infinite significant figure 5.0, 5.00000, whatever 0 you can put. So it has infinite significant figure, it has the 3 significant figure. So in the product, we take the minimum among all. So what is the minimum significant figure you have? 3. So answer will contain the 3 significant figure. Understood or not? This rule has made, because otherwise so much big approximation will come in the result. Okay, so when you have the constant multiplier, their significant figure we can take as an infinity. So that's why they will not be the deciding factor. Other quantity will be the deciding factor. So number of significant figure, what you will take? This may have infinite significant figure, and this will have the 3 significant figures. So when you will multiply, what you will get? So 5 4s are, what you are getting? 11.2. Okay, so answer is the 11.2, not 20. Then 20 you are adding, so it will be the 4 significant figure. Nayak. So answer will be 11.2. It has a 3 significant figure. Okay, so answer is 11.2. Similarly, like, so you will remember, no need to write now. So when we have the numeric multiplier, we can consider the infinite significant figure. So they will not decide the significant figure in the product. Understood? Okay, like suppose radius of the circle, radius I am giving 1.24 centimeter. Okay, what is the diameter? So diameter, we know that D is equal to what? Diameter D is equal to 2R. So we know that the diameter is the twice of the radius. Again, this 2 is not the experimental data. It is only the multiplier. Yes or no? So this 2 will not be the deciding. This 2 we will take as the infinite significant figure. So diameter will have how many significant figures? 3 significant figures. So diameter we can write up to the correct significant figure 2.48 centimeter. Understood? Now everybody got it? Okay. One more, like T is equal to 2 pi under root of L by G. So here suppose L has 4 significant figure. It has the 5. I'll leave it. It has suppose 3 significant figure. G has 2 significant figure. So in the result we have how many significant figure? In the time period, how many significant figure we will have? 2. Why this 2? Infinite constant multiplier. Pi is also the multiplier, and pi is not 3.14. Pi we can write up to the what? non-terminated decimal. So many places we can write. So pi, don't think that pi is the 3.14. 3.14 has the 3 significant figure, but pi does not have the 3 significant figure, because pi approximate value we write as a 3.14. Okay. So pi will not be the deciding factor. It is a constant, the numeric multiplier. 2 is the numeric multiplier. So L and G we have to only check. So L 3 significant, G 2 significant. So product will have 2 significant figure only. So T will have 2 significant figure. Understood? Everybody got? Similarly, one example they gave in the NCERT, they gave the side of the cube. Side of the cube is the 2.304 something they gave. 2.304 centimeter is the side of the cube. Now they are asking the surface area of the cube. So surface area of the cube means 6a square. Surface area of the cube is 6a square. A has 4 significant figure, 4.203, 4.203, 4 significant figure. A has 6 I am multiplying, but that 6 is what? This 6 I am multiplying due to the 6 faces the cube has. 6 faces the cube has. So 6 is the multiplier only, not any data, experimental data. So that's why surface area will have how many significant figure? 4 significant figure. Okay. Everybody got or not? Okay. So this is the significant figure and that notation and round off. Now vernier calipers and screw gauges remaining. Hungry? Because vernier calipers will take more than half an hour, 45 minutes around. So one day maybe in the any time I will take the extra class to cover it. Okay, because some batch is lagging. So one day I will announce earlier, and then I will complete the vernier calipers and screw gauge there. Okay. So I'm not starting now, because if I'll start, then it will take more than 30-40 minutes. Okay, 45 minutes around. Okay, then bye bye. Bye bye.